Hey guys, it's Tiny Tom Logan back with another video for you, and it's not very often I make a video about the same topic over and over again, but in all honesty it does feel like I kind of have to. Now I did make a kind of insert into my Strix review, the X299 Strix review here, about VRM temperatures. In reply to something that Der auer had put up in a previous video. Now what I'm going to do is I'm going to put all the links to Der auer's videos underneath, and I do need to make a couple of things clear about what's been going on with Der auer as well. So if you're interested, get comfortable, because it's all lots of chitty chatty stuff, although I am going to be showing you some stuff in the BIOS, some results from screenshots and stuff. It's very much kind of an information and data dump at you guys, so you know what we have been up to. So I mentioned in the ROG Strix gaming review that I was struggling to be able to match the kind of temperatures that Der auer was saying that he was getting on the X299A. So I had a look at it on the Strix. Now something that you do need to realise, and it's something that has kind of been missed with a few people, not Der auer, before you think I'm saying that, is that the X299A and the Strix are incredibly similar boards. If you were to strip all the heat sinks and lights and all that sort of stuff off of them, they are so ridiculously similar, it's unreal. It's pretty much like they're the same board, but one of them's got a kind of gamery type of dress over the top and it's got a few more lights and stuff like that. So they're pretty much the same board, which is kind of a weird thing to say. You've got a white one and then you've got a gamery one with loads of RGBs and stuff. So when I was using the Strix, the fact that I was doing that review, I was actually almost ready to publish my Strix review anyway, and I saw the Der auer stuff, I knew about the similarities, so in my head it made sense. I will nail it on top of my Strix review. But then a lot of people in the comments and stuff were kind of saying, oh no you can't because yours is a Strix and that's a ROG board. And so essentially what happened is, after me posting my video of me not being able to get anywhere close to Roman's temperatures on the VRMs, and I used exactly the same testing mythology that he did. So essentially I had a heatsink probe on top of the heatsink at the front of the board, and then I had a heatsink probe behind the VRMs on the back of the board as well, exactly how he did, so it was comparable. So then what essentially I did is I've moved on, or back. Okay, so I had a courier turning up. Anyway, so I've basically gone back and I've rebuilt the X299A, which is what Der auer was first talking about in his video. And then I've tried to kind of keep my test rig as close as I possibly can do to what it was before, but also in a weird kind of way do what he's been doing. So a lot of people were saying to me about the fact that I had an AIO in the roof was cooling my VRMs. So what I did it in the old video, but you can see on this one, without sticking my finger in it and trying to cut the top off, the cooler is out now. Now I do have a fan here at the moment, but the best thing I can say is that during the testing, it wasn't even in there. But that fan is going to feature something that we're going to talk about in a bit. So it's in there just because that was the last thing that I've been testing. So I've got the 299 in, and I've got my 4.5 gigahertz overclock in with 1.235 volts, and I'm going back. Now, something that Roman did say, Der auer did say, 400 watts load, which I could easily replicate, and I wasn't being able to get the kind of temperatures that he was. But something that wasn't particularly very clear in the original video is that wasn't 400 watt system load. And even though there was a few people chatting around online with Roman and they're like, well, I've got my power thing in the wall and I've got 400 watts being pulled and they're not getting hot, it was actually 400 watts being pulled just by the VRMs. So it wasn't a system load at all. It was actually over 500 watts system load. Now, I'm going to have to explain a few things to you anyway. Now, I test with OCCT, and that's my load program that I use for my reviews. There's a couple of reasons why I use it. You can set a maximum CPU temperature and it will actually turn the benchmark off when it hits that. So that's a really good thing for a reviewer, because I can click it and I can walk away, I can go and work on something else, I can make a cup of tea, do you know what I mean? And I know that if I come back and it's stopped, then it's either not passed, something's unstable, or we've got too high a temperature. But also you can set time limits on it as well. So you can say, for argument's sake, you want it to have a 10-minute warm up and then a 30-minute load time and then a 5-minute cool down before it stops. There's loads of things like that you can set into it, which make it a brilliant program for someone like me that's trying to do quite a few things at once. Roman was using Prime 95. Now there are a few different versions of Prime 95, but I've ended up downloading, I'm just going to double check for you while we're on camera because I can't remember what the number is that I've got. I've got V28.1 build one on mine at the moment, but there are different versions of Prime that have got different versions of like AVX in it and stuff like that. It'd be really great if the Prime people could have a really simple tick box which one that you actually want to run, because that would make this actually really cool. But anyway, Prime will pretty much just run and run and run and run. Now, something he did say which I don't agree with, and please don't think that I'm arguing or anything like that, because I have been in direct contact with Der Auer over Skype all week, and to be honest with you, after the way we've been chatting this week, I genuinely would like to go and shake the man's hand and buy him a beer, because I have personally thoroughly enjoyed the fault finding, because sometimes when you're doing motherboard reviews over and over again in CPUs, it gets a bit monotonous. So you get something like this that pops up that you can't work out, and suddenly I'm like, no, I want to know what it is, and you just want to get involved. Now I'm really grateful with the fact that Roman would even give me the time to talk to me about this and help me find out what was happening. Now essentially what was happening is our issue before is I was lynched on to the 400 watts, and he hadn't been specific about it being 400 watts through the VRMs. I think he did say system power anyway, so it was just a bit of confusion in the video, but that was where our communication problem had been. As soon as I knew that I needed 400 watts just through the VRMs, then I knew that I needed to bring more power in. Now, something that he did say is he said that OCCT goes up and down. Well, the problem is Prime actually does it as well, but it doesn't have the graphical interface to be able to show you that in between the runs, it will slow down. But if you watch the temperatures on Prime, your VRM temps and your CPU temps drop. And it's normally when it says, for argument's sake, you have certain tests that it runs through, and when it's finished the test, you have a core that will finish the test, and you have to wait for all of the cores to finish the test, and then it will start new ones, and it's in between that gap that the temperatures drop. Pretty much all benchmarks do it. So OCCT and Prime are very similar in that respect, apart from OCCT has a dirty great big graph at the top, so you can see the CPU loads drop, and Prime doesn't. If you wanted to see it in Prime, you would have to open the like Task Manager or something at the bottom. So anyway, with Prime, there are a few different options when you first go in there. When Der Auer was saying about his FFTs and all the thing, which you can basically plumb in at the bottom, the ones that I've pretty much concentrated my two on are the simpler ones at the top, and you've got maximum power and you've got maximum heat. Now the maximum heat right at the top, the small FFTs, absolutely just pummels your system. Absolutely, just rips it to bits. The maximum heat I can actually run for a bit longer. And one of the things I do want to say is, when I was first running those Prime benchmarks, 4.5 gigahertz, 1.235 volts, and then essentially I was loading up Prime, and the small FFTs, I would literally click run, and it would the system would totally shut down in an instant. If I was to run the in-place FFTs with maximum power consumption, that used to finish one batch of tests, and as it started the second batch of tests, that would then also, just on that second batch, as it started, it would go bop and the system would go off. And I was telling Roman about this, Der Auer, I keep calling it anyway. So I was telling Der Auer about this, and we were like, and he said to me, have you turned off SVID? And I was like, no. Now, don't get me wrong, in the BIOS, it does say that you should disable SVID so that the CPU doesn't communicate with the external voltage regulator. So I did that, and with just that turned off, I was still having the same issue. The kind of holy grail moment come where if you go into DigiVRM in the BIOS, there is a setting to be able to increase the current rating for the CPU. So on auto, it's basically 100%. But you have a setting that you can plumb in, and you can change it, and it goes to 140%. Once I did that, all of my shutdown problems stopped. And then we were into the point where finally I was seeing well over 500 watts load being pulled from my system. So we're like, okay, Der 8auer, we've nailed it down, we know what's going on. I can now see your 500 watt test, because if you take away about 100 watts for the system load, and I was using hardware info, and I could see with my that I was pulling 400 watts plus sometimes down through the VRMs. It was like, right, okay, here we are, and the temperatures were instantaneously there as well. So it was like, okay. But there's a couple of things that you do need to understand. At 105 degrees VRM temperatures, yes, you do get throttles. And when it does throttle, it can go down to 1200 megahertz. I've actually seen 700 megahertz where it's literally just going and almost to the point of shutting down, but it's throttling itself right back. But the problem is, and there is a problem there if I'm honest, is that because I don't have a delidded CPU, my CPU temperatures are an issue well before the MOSFETs become an issue. I mean, with the maximum heat run, almost instantly, like within seconds, my CPU was above 100 degrees. And this was another thing that I had to disable in the BIOS as well, is I had to disable the thermal kind of shutdown feature and fix it to be the absolute maximum that it could be. I didn't do my TJ max kind of offset that Der 8auer was on about. But what it does mean is you get to a point, and again, it's about 105 degrees for your CPU. That will then start throttling itself back. But it does, once you get to about 100 degrees anyway, you'll actually see that the CPU will be going back. Now, he did say that CPU-Z isn't that great for the very quick throttles that you can get on your CPU speed, and that's right. But if you open Hardware Monitor, it does actually track the minimum, the maximum, and the current value for your CPU speeds. You can do it with your clocks, you can do it with your voltages, there's all that sort of stuff in there. So I've always had a way of tracking my CPU, and I do it in every benchmark that I do as well, and you know, every CPU, every graphics card, everything. So I've always got that there. But it's also been really handy because he was using core temp to watch for a very minor fluctuation, whereas with Hardware Monitor, it actually stores it there for you as well. So once my CPU was even starting to get to about 100 degrees on some of the cores, not necessarily even all of them, I was getting throttles. Almost instantly, my CPU running that maximum heat one would drop from 4.5 gigahertz and it was down to 4 gigahertz, 4.1 straight away, just because of the amount of heat that was going into the CPU. And if you left it going for ages, I could get it back to 3.6 and 3.3. And the only time that I would be able to get a full-on VRM throttle, where it went right back, is if you leave Prime running. I'm not sure whether it's the second or the third test that Prime runs. It's by that point, the VRMs have warmed up a bit, so that when you do get the cooldown period, they're actually still quite high. And then when the load comes back in again, it does go up, and the VRMs do go above 100 degrees, and it will start to throttle back. But just so that you're aware as well, there is a feature in the BIOS where you can actually change the throttle point of your VRMs as well. So if you're worried, you can go into the BIOS and you can turn these down if you like. So if it's something you're concerned about. So the point is, yes, I have worked out how he was getting his throttles, but this is the bit now where I have to be very clear about stuff, and I'm not trying to cause an argument, I'm just giving you all the information. So OCCT didn't put enough load on the CPU for me to get that throttle. but neither does any other benchmark program that I use. Normal use, it won't. I've tried, we tried some, you've got the GIMP stuff on here. This is basically the GIMP testing that's on this will pummel your CPU. But I tried folding at home and I didn't have any issues. I tried 3D rendering and we didn't have any issues. So there was stuff that we were doing with Blender and like massive like 90-minute runs with Blender. We weren't getting any issues. All of the other games and stuff, that's not really ever going to touch it. But with all of the other benchmarks, my watch and my phone and everything's going nuts now. With all of the other stuff that we would normally test and we would use, and we would say even, you know, OCCT we say is absolute, is like extreme. We couldn't get it to do it. And if people are wondering why I use OCT and it's not as strong as you think, the problem is we've been using it for so long, it actually gives us a direct comparison. We may now bring Prime in, but we'll do OCCT still the way that we were, and we'll use Prime in possibly a different way. But it's something that, you know, I'm going to need to research and stuff now. So with all of the other benchmarks, we couldn't get enough stuff plumbed through. When I did start using Prime, like I said, the system was turning itself off. It was saying, we're not happy with how much this is pulling, turn it off. Now, the way around that is you either reduce your overclock or you reduce your volts. Or you can go in and you can turn all the safety settings off, which was what we had to do to force it, well, not force it, but allow it to pull all these extra watts. So you have to go in and you're pretty much turning the overcurrent protection off, because by allowing it to go to 140%, that's above, you see what I mean? That's where the overcurrent comes in, and you're turning the SVID off, so you're essentially, CPU's not talking to an external voltage regulator, it's just the external voltage regulator, which is the motherboard, is basically making all the decisions for the CPU. So we had to go in and we had to do all of that, and you also have to run Prime. It's the only thing that any of us have found that can pull this amount of watts. So with it being a problem for an end user, if you use Prime or you want to use Prime, yes, you will have an issue. There's absolutely no way around it. Even at 4 gigahertz, because I did test it, so 4 gigahertz is basically what I would call a stock run. 4 gigahertz CPU, 1.1 volts. The CPU was hitting 80 degrees, even with the 280 millimeter ARO, and those fans were on 100%, we were still getting 80 degrees plus on the CPU, and the VRMs were still just about getting to 80 as well, so that's even at stock. As soon as you start to turn the volts up, to play around with the volts, to do your overclocking, the power usage absolutely just romps up, and that's also when the power usage goes up, that's when you have problems with the VRMs. Oh, deep breath. So we found all of this stuff out. Now what that does mean is for you guys at home, I've had 4.6 gigahertz, happy as Larry, running at 1.235 volts, and it's passed every benchmark that I would normally use. Prime is the tripping point. If you introduce Prime, like I said, it's just going to turn itself off because it's not happy with the amount of power that it pulls. So you have to go in and disable all those things to let it kind of go run free and run wild. So I wouldn't necessarily say that the boards are not designed for all of this stuff. It's just the fact that we are kind of pushing them much further than anyone really thought was going to happen, because what you do need to keep in mind is as long as I can remember, Intel power usage has gone down and down and down and down and down, and then all of a sudden this time they've gone up, and even more so if you run Prime. You know, the power's just ridiculous. I mean, 400 watts through the actual boards is ridiculous. So there's some very specific scenarios that you have to do, and you have to disable certain stuff and use a certain program, but you can trip it over. But like I said, the problem is it is just Prime. I've actually run some benchmarks today where OCCT would find find an overclock unstable, and Prime wouldn't. Prime was keeping running and running and running. It was lower stuff, but essentially I was getting to the point where I was just undervolting rather than overvolting. So I was doing like a reverse overclock and trying to find instability, and OCCT was finding instability and Prime was just happy to keep running. Weird, but it's the best way I could try and, you know, go. So I'm quite happy to keep using Prime. I just see, so I'm quite happy to keep using OCCT, but at the same time, I'm Prime I'm seeing as like this, just like this massive power tester. But something I do want to say, and it's something that if you've been around the kind of industry for a while and you've followed like graphics cards, if you've only had your rig a couple of years, you probably won't know or have heard of this. But there was an issue with graphics cards a few years ago where Thermark basically was killing graphics cards. You turn Thermark on, it's now, MSI use it in Afterburner, it's called Combustor. There's a few different versions of it. There's even a version of it in OCCT for testing NVIDIA graphics cards, and it looks like the furry donut that moves around. Well, that at one point, the original Thermark was killing graphics cards. You could turn that on, the power and the load would go right up, and the thing was, is AMD and NVIDIA, what they did is they basically went, yeah, it's killing stuff. So they pretty much, if in the drivers, they set it so if it saw Thermark running, it would only let you have 50% of the power, because it was a very, very unique set of tasks that it was running. So they just basically, they gimped Thermark in the drivers because people were just killing their graphics cards. Quite wrongly, there were a lot of people that were fed up with their graphics cards or wanted to get new ones and would just leave Thermark running, kill the card, anyway. So that was another kettle of fish. But I can see something similar possibly start to happen with Prime now. I'm not sure how they're going to go about it, but this is such a unique and I know a lot of people use Prime, and I'm not telling you to, but essentially what I'm saying is I can see there being a Prime button now added into like the BIOS or something that you have to disable to be able to get the full power. So right, with Prime and OCCT and stuff like that, I've given you all of that information. I've spent days and days working on this with Der 8auer, but the bit that I can't kind of get past is if you don't use Prime, it's not an issue. I can get a much higher overclock with stability, runs all of the other benches fine. It's just Prime that in the end is the tripping point. If you want to use Prime, or that is going to be something that you are going to consider, then you just reduce your clocks. But digging in a little bit more and trying to get it so that, you know, no Tom, I just want Prime and I just want maximum. Basically, I went and I drilled at ASUS and I was like, right, okay, so I need 2 questions answering. And what I asked them for was how much power can the VRMs push, you know, at a maximum, and what's my maximum safe temperature. I've got to admit, they weren't very helpful. They're doing this big thing now where they want to control and they want to make a statement and they want to put it out. So despite the fact that I've been working on this for a week, they didn't really give me much help, and it's really kind of it's annoyed me. So yeah, that annoyed me. But essentially what I have found out is the best that I could get from them, and it was literally asking questions, and they tripped them up and they were like, everything that you're reporting now, the boards are capable with. It's just the fact that they're getting a bit hot. And we're talking about the VRMs. So the VRMs are absolutely fine with pulling 400 plus watts. So the VRMs are not running out of spec. Now, I have to admit, I did think pushing them this much, I thought they were getting hot because we were effectively not overclocking them, but I thought we were asking them to deliver too much power. Apparently, they're not. They're absolutely fine at this. It's just they're getting a bit warm. So, because I did think that, you know, we might end up putting a water block on the VRMs and cooling them down, and they're still going to be running outside of their kind of normal kind of power delivery, but that's incorrect. So what Der 8auer has said about getting a water block on them or better heat sinks is absolutely spot on. You know, now I've been and asked ASUS and done all of this stuff, and don't think I'm questioning or trying to trip him up. I'm just doing, rather than just taking someone's word for it, essentially what I'm doing is I'm going to ask questions. You know, what would happen if we were to run these rigs with 400 watt VRM load, but we kept the temperatures down? And they were like, it would be fine. They're all right with that. That's cool. But that was then what led me on to this. And this is why this heatsink is here. Now, weirdly, with that heatsink on, my 105-degree tests then dropped down to like 70 odd degree tests. And the CPU temperatures come down a bit as well. So it is 100% just a massive amount of load on the VRMs, and they're just going nuts. But the thing that I do want to kind of draw your attention to as well is you've only got a small bit of real estate between the memory slots to be able to put your VRMs in and put the heatsink on. Yeah, all right, we could put bigger heat sinks on them, but you need to think about if you have a tall heatsink, people are going to moan that they can't get their air coolers on. People are going to moan that you might not be able to get your AIO in the roof. If it's too tall, it could end up hitting. There are some cases, like the one that I'm using with mine in my rig now, you know, I've only just about got room above the board for fans. And, you know, so we might end up getting to the point where, for argument's sake, you get a normal heatsink in the box and then you get a massive heatsink in the box. Like back in the days with like the original Rampage Extreme, they had extra bolt-on things with massive things, and so we may get back to that. Now, I don't particularly think that's a bad thing. I think if Der auer bringing this up means that we're going to end up getting some interesting and new products coming through, then, you know, that's all good. But I can't get away from the point that under normal use with even gaming and even big overclocks, as I've shown with my 4.6, it's not an issue. So we're going to have to see if we can find any other programs that put this kind of load on, just so that those people that use those programs are aware that they're going to have to add in extra cooling, might need water blocks, and all of this kind of stuff. So that really is what it all boils down to. Yes, I found out how to get that much load put on, and it was just some confusion with the bench that we were running, but also that it was 400 watts on one component or one batch of components rather than the whole system. And then I just dug and dug and dug and dug and dug, and I've literally spent like 3 days testing this thing, and, you know, literally pulling air coolers out and stuff, because I pulled the AIO out just so that people couldn't say it was getting artificially cooled. It didn't really make a great deal of difference. Having it in there, all it ended up doing, if I'm honest, is it delayed the point that I ended up getting the thermal throttle. It didn't stop it entirely, and that was even though I had these fans running at 100% right above it. So there's lots of little things like that. So one thing that I would like to say, and that's a very clear point, is that if you would like to go and see either of Der auer's videos, I'm going to put links to them underneath. I'd like to thank him very much for, you know, discussing things with me on Skype. I don't care whether you guys think that I've done a bad job, should have kept my mouth shut in the first place. I genuinely don't give a monkey's uncle, because I've thoroughly enjoyed looking at this, and I've personally learnt stuff from it as well, which at the end of the day, none of us are perfect. And like I said, I've learnt from it, and it's going to be something that I'm probably going to be the biggest moron about looking about this sort of stuff now going forward. Although, to be honest with you, I have an ITX board here that I've been doing MOSFET stuff with, which is probably going to be a next video, and that was actually in progress before we got to this. But with what Der auer's been showing me, and with hardware info and stuff, it's actually just gave me more data, and I've ended up retesting some stuff. So it's actually all been good. So there is no he's done it wrong, there is no that's done it wrong. We just went about the same sort of thing in different kind of ways, but now we're on the same path. What it is going to mean is that I'm going to be paying specific attention to this with the boards going forward. It's going to be with all brands as well, so don't go thinking that this is an ASUS X299 specific issue. It's not. I wouldn't be surprised if one brand or one board is probably worse than this. It's going to come down to the way they go about things in the BIOS, because I'm going to assume that with voltage regulation and stuff in the BIOS, some brands can be better than others and worse than others. So this could all then correlate into earlier throttling, and it's going to be a minefield of stuff. But my parting comment is, this isn't a system-wide issue. It's not a platform-wide issue. Well, it is, but only with very, very specific use. So if you're going to build a system for, you know, I don't know, rendering your videos, making your games or stuff like that, or even gaming, if you're going to go that way, you're not going to have an issue. At this present moment in time, our big kind of trip up point for the VRMs is Prime 95. And if you keep that in mind, it might not be such an issue. But don't forget what I'm saying. I'm not saying this is an ASUS issue. It's not ASUS issue with Prime. It's X299, the system, the platform, the amount of power that the CPUs are drawing really is the issue. The other thing that I would like to say is, at the end of the day, we have got a small amount of real estate between the CPUs. So some E80X boards, we might be able to get some more power phases in and a bigger heatsink, and then that will mean that the power phases will have the load spread across them better, and a bigger heatsink might drop the temps down. It's not like Z270 where you have the massive kind of heatsink right the way around the side and like 10 or 14 power phases with the power spread out between them or anything like that. If anything, the fact that you've got DIMMs, as in memory, either side on X299 is part of the reason why we're having this problem, and the fact that Intel have suddenly surprised us with a CPU that's pulling more power all of a sudden. So there's a lot of little things that have gone into it, but I don't particularly think that the big hoo-ha and everything, I think it was kind of a bit overhyped, and we just need to realise that there's just some very, very specific criteria that needs to be met, and then you can get hot VRMs, or you need to pay attention to cooling your VRMs to stop the throttling. But what we have been doing, me and Der8auer have been doing, is trying to find these specific things that are tripping it up and causing this power usage, so that we can make sure that we know how to get it to do it now. And now what we can do is we can go and see if we can solve it. What cooling do you need? Can we change it with a heatsink? Is a water block going to make much difference? These are all things, it's all going to evolve, and it's definitely going to change over time. And as stuff happens and stuff, it's going to be, it's actually going to be quite an interesting one to watch. He's actually been saying to me on Skype about getting some specific thermal pads to even try and get the heat sinks that come standard on the boards to work better. So there's loads of things like this, and it's, to be honest with you, it's going to make reviewing any X299 board actually a bit of a minefield. Like, oh my days. But anyway, with the memory card on my camera now flashing up red telling me to shut up because I've been talking too long, I have done my kind of like information dump for you. I would love to hear your thoughts on underneath, even if you think I've done something wrong. Let's talk about all this stuff. I'm going to keep an eye on the comments. You can also come and join the thread on the OC3D forums as well, because we've got the forums there. We can come and discuss it. And if you don't get your verification email come through, just use the contact us button underneath at the bottom of the website, and that comes through to me directly. Tell me a username and I can add you manually. It's just sometimes your email provider can either stop the email coming through, or it's just putting it into spam. So if you're interested in joining the forums and you've not got that verification email, it's probably just not going to be letting you post, then like I said, use contact us and I will add you manually. Thank you for listening. Thank you to Der8auer, and I'm looking forward to seeing how this all develops. But for now, at least, with a lot of chatting done, this has been Tiny Tom Logan out. Ding. This has been Tiny Tom Logan out. No, this is Tiny Tom Logan out.